Hi, have you ever wondered how the mesmerizing patterns that you see during concerts are made possible? If you did, then you have come to the right place. Hi, I'm Pendulum, and in this video, we're going to explore the captivating world of the pendulum wave model, where we will dive into its potential implications and how it applies in our daily lives. We'll also look at the significance it holds, especially in the realm of science education. And finally, we'll look at the underlying principle that dictates the beautiful wave motion that it produces. So join me in this intriguing journey into the world of pendulums as we venture into a journey to unravel its secrets. So as you can see in this pendulum wave model, we have simple pendulums. So a pendulum wave model is basically a collection of simple pendulums, each of which are of different lengths, oscillating at different frequencies, but in a synchronized way, as you will see shortly during the demonstration. So the length of each pendulum were determined by using this equation. So the length of each pendulum were determined by using this equation, whereby L stands for the length of the pendulum in meters, G stands for acceleration due to gravity, and T by 2 pi, that's simply the constant here. So T max stands for, that depends upon the designer. So if you want the wave pattern to persist for, let's say, 20 seconds, then you give the value of Tmax as 20. Likewise, if you want the wave pattern to persist for 40 seconds, you give the value of Tmax as 40. Our group decided that we wanted the wave pattern to persist for 24 seconds. That's why we gave the value of Tmax as 24. Likewise, as you can see, we have two more variables here, K and N. N is simply the position of the pendulum across this arrangement. So if you want to find the length of the second pendulum, you give the value of N as 2. Likewise, if you want to find the length of the 10th pendulum in this arrangement, you give the value of N as 10. The last constant K is what we need to solve for. So now that you have all the values for Tmax, N, 2 pi G, so all you need to do is substitute these values into this equation and you will get the value of K. We got the value of K as 0.23. After we found the value of K, we just substituted into this equation and then we determined the length of the remaining 15 pendulums. So this is the length of the remaining pendulums that we got. The length of the first pendulum was found to be 0.23 meters. Likewise, the length of the second pendulum is 0.211 meters or 21.1 centimeters. And so the list goes on till the 16th pendulum, which is the shortest pendulum, and its length was found to be 8.9 centimeters. Now, before I explain further, let me demonstrate. So as you can see, the pendulums are of different lengths, and hence by the time period formula, they rotate at different speed, and the time it takes to complete one oscillation is different for each pendulum, because the time period of a pendulum depends on its length and also due to the acceleration due to gravity. So by the formula, the first pendulum, which is the longest pendulum, took the longest to complete one oscillation, because time period is directly proportional to the length of the pendulum. And so the second pendulum takes lesser time than the first pendulum to complete one oscillation, and so it decreases. The time taken to complete one oscillation decreases down this arrangement. So what that means is that the last pendulum, the 16th pendulum, which is of the shortest length, will take the least amount of time to complete one oscillation. Because of this difference in the time period of the pendulums, the beautiful wave pattern results. So this has many potential implications. It can be used in a wide range of fields. For instance, it can be used in the educational field, whereby the teachers can use this pendulum wave model to explain concepts such as time period, amplitude, frequency, and by using this model, the students will be captivated and they'll be more interested to learn. So this is one of the educational application of the pendulum wave model. Secondly, it is also used to study the magnitude of earthquake. It is also used to study the composition of the crust of the earth. And as I pointed out earlier, it is used by artists to visually captivate their audiences. Now, before I conclude my explanation, I want to point out one more thing. This pendulum wave model is an excellent example of the wave motion and energy transfer. So what happens is when the first pendulum is at this extreme position and it goes to this other extreme position, it transfers some of its energy to the second pendulum, which then uses this energy to swing at an increased amplitude. And so this whole cycle of energy transfer continues until, due to friction and hence loss of energy, the energy is dissipated, and hence all the pendulums goes out of sync. So this, as I pointed out earlier, this pendulum wave model is an excellent example of wave motion and energy transfer, and should be used by every teachers to explain these concepts in a very interesting way, because students learn better when they are captivated by certain visuals. Thank you.